With the recent popularity of RC-controlled vehicles, the upcoming potential of 3D printing, and the abundance of smartphones, we decided to create a product which utilizes these three things.
The idea is to have a box that can be put into a 3D printed car, plane, boat, helicopter, quadcopter, or anything else the user desires. Then, through a smartphone app, the user can wirelessly control what they have printed.
After a bit of research, we constructed a plan. Although the theoretical design allows for unlimited possibilities, a quadcopter and car will be the focus of our initial prototype. Our design uses an Arduino Mega with the ATmega2560 as the microcontroller,
A GY88 10DOF IMU,
a JY MCU Bluetooth module,
5 8C SR04 ultrasonic sensors,
4 30-amp Simon K electronic speed controllers,
4 HJ2208 brushless DC motors,
and finally an 11.1 volt 20C 2200 mAh lithium polymer battery.
All components will be fitted inside a 3D printed container and interfaced through a custom-made PCB. The box and motors can be placed into a 3D printed quadcopter and flown, or placed in a 3D printed car and driven.
Once all components had been ordered and shipped from the Hong Kong distributor Deal Extreme, we began our testing. For the quadcopter, we use the open-source Arduino program MultiWii. Although MultiWii has most of the hardest parts already complete, getting all the components to work as intended was difficult and took many weeks. Using an Android app called EasyGUI, we were able to see information sent from the box wirelessly, as well as control throttle, yaw, pitch, and roll. With a combination of SketchUp and Blender, we designed the chassis of the quadcopter and the car. Then by using an UP 3D printer, all models were printed off.
The printing process was slow and could take hours per print. It didn't help that every single print failed at least once. Most of the models were split up to be printed individually and assembled later because of restrictions on the size of the printer.
With EagleCAD, we designed a PCB which uses header pins to sit on top of the Arduino Mega and organize the connections in a simple and efficient way. Using a CNC milling machine, the circuit was drilled into a copper board and then constructed with some soldering.
Once all components were assembled and working, it was time for a test flight. We reached this point about a week before the due date of the competition and decided to drop work on the car and complete the quadcopter.
After many failed attempts, over 120 hours of total work each, and over $500 spent, we were finally somewhat successful. After our first successful test flight, on the due date of the Brightsparks competition, the frame of the quadcopter was destroyed in an unexpected loss of throttle.
But it was just the frame that broke. The electronics remained intact. Although it may seem like a bad thing, this accident happens to also be a proof of concept. The frame can just be reprinted and flown again.
So in the end, we didn't accomplish as much as we had intended to. It all came down to a lack of time. but at the very least, we flew a 3D printed quadcopter and showed off the concept. Because the idea of the box is to allow users to operate RC vehicles with ease, we have given it the simple name EasyRC. Even though technically it used Bluetooth, EasyRC sounds a little better.